Hey everyone, welcome to episode 229 of the Manufacturing Hub. If you're joining us live this Wednesday afternoon, welcome. If you've been here before, obviously, welcome back. Today, Dave and I are going to be talking about manufacturing architecture, and we will obviously start in a couple of minutes with the definition of what that is. Both of us are doing a lot of work when it comes to the SCADA and MES, and obviously the control systems layers. So it is very important to be having these conversations and having discussions as to some of the pain points I would say we experience, but also some of the solutions that we see for some of those pain points. So we're going to be sharing a couple of stories. We're going to be discussing the different nuances when it comes to obviously the different verticals, but also the different stakeholders that have these kinds of challenges. But before that, we do have a couple of community comments. So, number one, Dave and I will be in Sacramento for the Ignition Community Conference. We've already made a couple of announcements on that side, but if you have not purchased your ticket yet, we will definitely be there in the middle of September. If I'm not mistaken, it's the 16th, 17th, and the 18th of September, the actual days of the conference.
Mhm.
We'll be there a couple of days before. If you ever want to reach out or connect with myself or Dave, don't hesitate to send a message. We will also be shooting a couple of pieces of content at the conference. So if you would be interested in speaking with us, I know we have a fairly tight schedule, but reach out and see what we can do. That being said, there's also a different event happening at the same time in Atlanta, which is also very interesting. Our friends from Siemens are going to be there and we'll be presenting quite a few solutions. I've been talking a little bit, obviously, off the screen to some of them. So there's going to be interesting updates to be seen on a lot of the different topics that Dave and I are releasing currently. If you're on LinkedIn through some of the content that we had created at Automate, so if you're interested in that, there's obviously going to be a lot of different vendors besides Siemens. It is not a Siemens only event, but it will be in Atlanta. It will be during the same week as the ICC. But if you're in that part of the region or the world, make sure to definitely check that out. Dave, anything that I've missed that we want to add to the community comments?
No, I think we're super excited to go continue to dig into some of these architectures.
Mhm.
Vlad and I have talked about it on a high level, on and off for the last couple of years. But what, 2, 3, 4 weeks ago, whenever it was that we were talking about kind of manufacturing intelligence and how to go through the process of building those projects and yeah, go and build those projects. I've had several people, at least on my side, reach out, say that they were enjoying it, and so I'm excited to hear that what we have to talk about here
Mhm.
today when we go talk about architecture. Having said that, Vlad, I feel like just the definition of architecture is like somewhere between 12 seconds at the it's the cables and switches and hardware that connect everything together through, like, I don't know, your CISSP book right over your shoulder, which is, I don't know, an easy 2, 3 thousand page read, sort of content. Would you, Vlad, like to go give a brief overview, the 45-second overview of architecture, or would you like me to go give the brief overview of architecture, and then the other one?
Let me I guess kick it off. Dave, it seems that maybe your stream, maybe my stream is freezing a little bit. So let me kick it off, right? So I think that there's no easy conversation around architecture, as you've mentioned. I think that architecture is basically one of those it depends type of answers from a consulting standpoint. But generally speaking, when we brought on guests to talk about SCADA, to talk about MES, to talk about historians in an isolated environment, the question as to what the network actually looks like, what are the components at the PLC and HMI side actually look like, all of that is going to be part of your architecture design, so to speak. And I would, I guess, argue that I think networks are to some extent the backbone of your architecture, but the decision is not only on the switches and the routers, the decisions are also, what kind of machine, or how do you bring in a new machine into an existing architecture? How would you do it in a greenfield environment? How would you make maybe some of those decisions if you're an OEM versus an end user? So I think that the architecture, in a very specific sense, maybe touches a lot of the networking equipment, but in a broader sense is also what allows you to create a strategy, but also an operational standard for how you're going to access the data, how you're going to accomplish, a principle, I want to say to some extent vaguely defined as the UNS in your specific instance. So for me, again, architecture touches a lot of different components, a lot of different stakeholders, but ultimately it does obviously imply a lot of the networking side when it comes to industrial automation and manufacturing. What is
Absolutely. And if I can just go, if I can add on to that, I feel like you did a really good job on the architecture, right? And I feel like the majority of groups that you talk to, when we talk about architecture, we think the PLCs, we think our edge devices, we think maybe our HMIs, our robotics, our machine cells that we're dropping in on the hardware side, on the on the software stack. It's like, how are we going collect this? What does our SCADA look like? What does our MES look like? Are we pushing it to a historian? Similar conversations that we've had overall over the course of the last month with several different
Mhm,
guests. I feel like on the networking side, specifically on the networking architecture side, we don't spend a lot of time talking about
mhm.
it. Or at least we don't spend a lot of time talking about it comparative and relative to its importance in relation to all of the all of the other hardware and
Mhm.
softwares that we go through the process of. But it certainly is the backbone in any organization. And if you hopefully make the decision of, I'm going to go make these choices, I'm going to go make these hardware choices, and then I'm going to go build a network that's going to go last the next 5 to 7 to 10 years, and will allow us to continue to grow and collect more data, et cetera. That is fantastic. I feel like on the network side, the network architecture is almost always the last piece that is considered, and sadly and shockingly, is on a fairly regular basis the part that fails, or a bottleneck in the solution that prevents some of your much more expensive, much more well thought out pieces of hardware and software from working correctly.
Yeah, and I think, maybe as we go through the conversation today, obviously each piece or each component hopefully builds on top of the previous one. We'll also tell a couple of stories, from our conversations in the field, and like I said, maybe at least shed some light as to what those conversations look like, and ultimately what were some of the failures. And so I'm going to start with I want to say, brief or relatively simple, and I put that in air quotes, simple story, because none of it is obviously ever simple. Dave, while I do that, double check. It looks like I'm not sure if we're broadcasting to LinkedIn based on the restream tag in the top right. But that being said, to start with the story that I have for you today, is a lot of my work has been on the data side, right? So this touches the SCADA and MES layers. And obviously, as someone who works on both of those sides, the usual request that you will get from an end user is an update for a new system that is being brought in on site. And that is a reasonable or normal request. Usually, what happens is if you have a piece of machinery, something new is going to come in. It's going to be new PLCs, new drives, therefore a new way to create said data. So basically, in this specific scenario, a site was bringing in or revamping their palletizing area. So they brought in a new palletizer with PLC, HMI, a couple of devices on Ethernet, an E1 Cozy. For those who are not familiar, it is a device that allows them basically to remote in, and a unmanaged switch within the electrical cabinet, right? And so we'll get into the nuances as to why that is in theory fine from a machine builder standpoint, but caused some issues on the plant level. So for me, being involved in the early stages of those conversations, I was immediately surprised by a couple of things. So number one, they wanted to deploy all of those devices as a set of unmanaged, network devices that they would give plant IPs to. And I subscribe to the philosophy of, you need to obfuscate whatever is not going to be directly on the plant floor or directly accessible. So typically your PLCs and your HMIs, it makes sense to put them on the plant-wide network, but your VFDs, your point IO, or anything that requires a much higher level of traffic and resiliency should probably be segmented. So anyways, that was item number one. And number two is, of course, that E1 Cozy. I remember even reading a post, Dave, and maybe you've seen this, where someone recommends that whenever you see machines come in with devices that try to bypass or allow somebody else to come in via an unsecure network, you should be basically turning them off, ripping them out of that panel, and sticking them somewhere else. But long story short, it definitely creates a scenario where now a traffic, or I guess a device that creates traffic from the cellular network to that machine, can now flow into the entire plant. And of course, that is not only a cybersecurity vulnerability, but also exposes the plant to traffic it has not seen, or is anticipating to see before. And there's other devices, right? So if you have servo drives that need to be high precision, that receive commands very frequently, vision systems, they had a barcode scanner, but ultimately those can also create a lot of traffic. So long story short, the outcome, I guess, of this entire exercise was that they put the palletizer on the network, they assigned the IP addresses, and lo and behold, the machine was unoperational, right? So they started getting a lot of errors on the PLC. They couldn't process the data coming from the vision system, and so they disconnected and had to bring in resources capable of segmenting that quote unquote network. And so the solution was straightforward, and we'll get into some of the diagrams in just a moment, but basically setting up a managed switch that allows you to use the NAT, or the network access translation protocol, to basically change the IP address of the private side into a plant-based IP address. And we're not going to get into the technical details, but basically it only exposed, as I've described, the PLC and the HMI. And of course, the outcome is very clear. It's a lot of time spent re-engineering the solution that should probably have been discussed with the machine builder up front. There was a lot of troubleshooting. The machine was, on that side at least, unoperational until it was disconnected for a couple of days. So obviously, what you need to figure out is the downtime worth, some of the dollars maybe saved on not creating the right architecture for that specific facility. And again, I would be very reluctant to place blame on either group, because I think it's a collaborative effort. And as a machine builder, it's hard to foresee what the plant environment is going to look like, but also as the plant, it's not always transparent what the machine is going to come in with until the sort of the very last moments. So anyways, that was the short story of how a palletizer architecture was a problem in some of my conversations.
Absolutely. I think it's interesting. One note, we are once again live on LinkedIn. We're having some technical platform issues, I suppose. It decided to stream to everywhere other than LinkedIn. So sorry that you guys missed our eloquent or ineloquent conversations on what is a systems architecture, and how does networking work with that. Vlad, I do want to go ask you a
Hmm.
question on your story, talking about those E1 boxes. I guess for me, I find it amazing how like full circle we've come, right? Like it wasn't that many years ago as well, like 8 years ago, maybe a little bit more, that E1, or kind of these remote access, remote terminal boxes, came out. And at first, everyone that on our plant floor, we hate that cybersecurity issue. Then other security, maybe more physical security, maybe it's more of an unknown. And then I feel like right before COVID came in, they were starting to gain popularity.
Mhm.
And then during the first couple of years of COVID, they just kind of exploded in popularity. And people were like, hey, as opposed to having engineering workstations, or as opposed to setting up, legitimate VPN access or any of these other things, we're just we're just going to go through these boxes out there. And then, we've got a box, 7 of our different vendors have a box. Everyone can go and hopefully look at only their pieces of equipment, but highly doubtful, many of these networks were segmented, and a correct way to go block down some of that traffic per your last story. What are your current thoughts? What are your 5 thoughts on E1 boxes, plug and play boxes for remote capabilities? Do you think there's a place for them? Do you think we should just kind of remove those and go to a more standard engineering cybersecurity approved solution?
Yeah, I mean, look, I think in very broad strokes, I think there is a place for them. As you know, I work with larger manufacturers, right? Medium to large size
Mhm,
manufacturers. I think that it is hard to justify not having an engineering workstation, even
mhm,
if it's in its most basic form, right? If you
mhm.
simply plug in a personal computer,
Yep.
again, it can be ruggedized, it can be put inside of that panel that runs
Mhm,
the software. I
mhm.
think it saves you a lot of different headaches, right? So
Yep.
you can connect over a cellular network and you can, I guess make things happen, but ultimately I've also experienced problems on that side if you disconnect, if you don't save your work, if the file becomes corrupt. So for me it's always
Mhm,
been easier to just, hey, like let's deploy a proper, and again when I say proper, it can be a, 8 gigs of RAM IPC that runs Windows with, again, RSLogix or Studio 5000 for that specific system that I can connect to over the cellular network, but at least the software is running locally. Now, the second comment is the trust level. I think it's
mhm,
very difficult to gain the trust of an end user, and I
mhm,
think that trust is very easily lost the moment you make not necessarily a malicious mistake, right? But if
mhm,
you sort of betray that trust by making weird changes, or if you decide to push an update and the machine is down for a couple of hours, and they even think that you were the one responsible for making those
mhm.
changes because you're the only one able
Yep.
to connect through that tunnel, you're going to be walked off that site. And I say that very in a very nice way,
Yeah.
but very promptly, right? And I've seen that, like I said, the reason why the post that I referenced was made is because a lot of, I want to say, people with that level of access or those tunnels don't take appropriate precautions to
Mm.
secure that access, right? And so it's,
I
uh,
yeah.
yeah,
I would say
so
I would agree. I would say some sort of workstation, some sort of IPC, some sort of jump box if it's on like the IT server side, to go ahead and punch a couple holes in the firewall, where everyone is aware of what happens on most medium and certainly large sized organizations. I think for smaller organizations who this is our only access, it's not the best way to do it. But I mean, when I remember the original E1 boxes, the price was in the hundreds of dollars, right? Like it was in the hundreds of dollars. So it wasn't particularly expensive. And if it meant you didn't have to go spend all of this time driving back into work when something may have happened, so that you can go through the process of solving a problem, it made a lot of sense, right? And it's given
yeah,
us, I mean, again, just like pre-COVID, now post-COVID, going and having those conversations of remote access. Like remote access for 50% of the facilities pre-COVID was, why would we ever need that, right? Like if I'm away from work, I don't want to be going and getting these messages. I don't want to see how we're running, as much as you think and people who do that sort of work know and understand the value to the organization. I actually want to go tell a story. I do want
mhm,
to go have a conversation of who do we think is responsible for that architecture, or calling out those. But first, I want to tell a story that I had not. It's a different story than I had anticipated. It is a story that I have not thought about in, man, nearly a decade or so. So everyone think about, Vlad's setup and generally how well it worked, and calling out potential hurdles and issues. I was was almost a decade ago. Was working with a group. I've done a bunch of work in the furnaces side, like furnaces, heat treating, that sort of thing, on that side. And so one of the groups that I was in, going and redoing and building their first SCADA, building their first MES, on ignition. They were also in the process of significant CapEx furnaces, and going and rebuilding the furnaces, and kind of the entire process that goes through that. So generally keeping the structure, but redoing all of the burners, sometimes redoing some of the belts, sometimes redoing some of the fireproof bricks, and other things like that, in order to make sure that it can go run for the next, I don't know, 10 plus years. So we were like the fourth party, and or maybe the fifth party in this, but there were the company who was coming in to go do this had in fact outsourced the controls work. And the person who they outsourced the controls work to, man, Vlad, he was a wild guy. He refused to travel. Yes, he refused to travel. They would regularly get in fights, the prime contractor and the subcontractor, this guy. But he was the only controls guy. He did all of the controls for all of their furnaces. And instead of showing up on site, instead of doing a crazy thing like sending one of those boxes or trying to get VPN access, which did exist, at that facility, do you know what he did, Vlad?
What
Do you want to guess?
was
We'll pause for we'll pause for dramatic
was it like a
effect.
team viewer
Would you
setup?
like to guess?
Like someone would bring in a laptop, team
Oh,
viewer, and then
Vlad, if it was only a team viewer setup, no, he sent another laptop, right? Like he sent another
yeah.
laptop. He was watching how the people were working, and apparently at some point he couldn't get like a good enough angle at the physical work they were doing. And so still in my Google Photos to this day exists a picture of the laptop on top of a ladder pointed down at the control cabinet. Um, it's how the other half lives sometimes, Vlad. I would not suggest or recommend, anyone doing that. I, I have distinct memories of all of us being very confused, mostly how the end user was paying what I have to imagine was a significant amount of money, for this. But man, it was just one of those, the exact opposite of let's go have a conversation around which network segmentation should we go put this in, sort of conversation, that you just had. It was probably on a cellular modem too. I mean, if I remember correctly, it was probably hotspotted to a cell phone on a cellular modem, going so that he could go, and he was watching he was using the webcam to watch the HMI screen to see what was in, the loops, on the furnace in and of itself. It is, there's Vlad, about as wild, and wacky as you could go. I would hope that there's like some wacky stack style music playing in the background. Needless to say, I do not believe he finished all of the furnaces. I believe someone else came in to go do the controls on some of those other furnaces, just based upon the arguments
Mhm.
that were going on, the audible arguments that were going on in the shared meetings.
Well, it's interesting that you say that. I guess I had a project that was very similar to that on a roaster, right? Where basically the engineer that
Hmm.
designed the system also was for some,
Hmm.
and I guess I didn't ask too many questions, but he was not on site. Instead,
Hmm.
it was a guy with a laptop, and then none of his licenses would work. So I had to, I guess, pitch in and try and help him get the PLC
Yeah.
up and running. It's interesting, I guess, to be able to visualize the system. Maybe there's an opportunity, and this is a suggestion for the E1 group, right? To create this Frankenstein of a, hey, here's the E1, and then there's like four IP cameras
Mm.
tied to it where you can remote into the system,
Mm.
but also there's clamps that you can position the cameras wherever you want, so you can see
Yeah.
what you're working on. But it
Yeah.
is also a concern, right? Because if
Yeah.
you're remoting in and you don't see the physical operations,
Hmm.
it is a bit sketchy to make changes.
Absolutely. I can understand someone else coming in and struggling to do the tuning or struggling to do the fine tuning, especially if none of the licenses works. no one else was there. Like he was a one dude controls person who just
Mm.
for whichever reason blatantly refused to go show up to site and sent several laptops. And was try I feel like there were some safety concerns in there as well. We don't have to get into it. I do want to go
Yep.
ask the question, Vlad, of going back to your palletizer example, right?
Hmm.
Of whose responsibility is it to go call out the necessary network things or the potential network issues or opportunities, or hey, if you guys are going to go through, put this on the network, connects it to this system, these are our suggestions and recommendations. Do you think it's an end user, or do you think it's the builder who should have like best practices as part of their doc? Do you think it's the end user who bears the full responsibility? Or do you think it's just kind of one of those slightly gray areas where the folks on site are going to go have to live through the pain of doing that stuff on site?
Yeah, I mean, look, I think that the decision ultimately lies with the end user. I think that when you have,
Hmm.
the early stages like an RFP, you should be able to identify,
Hmm.
and hopefully there's someone on the control side from the end user that will double check what the current standard is. Obviously, if there is no standard, then they should
Hmm.
be able to then say, hey, there's going to be some of these challenges as we put this machine on the production floor, because it's also going to, interface with the data systems and require some remote connectivity and whatever else that might be needed. Like I said, on the machine builder or OEM side, would hope that they have maybe the capability to accommodate those changes. I would also hope that, if they're selling palletizers to a small factory or to a very large customer, that they can ask also the question, here are the, let's say, two different options, right? So we have
Hmm.
one that is going to be much lower cost, that you
Hmm.
don't need to connect to anything, is just like a standalone machine. And we have a much, I guess, more quote unquote protected or more advanced
Hmm.
device where, we put some more thought into, the switches and the routers and some of those other protocols, because it will be connected to a plant wide network, right? So, but I personally don't see a lot of, I guess, like those thoughts being put in, which is why
Hmm.
I think machine builders can certainly benefit from understanding the architecture of different sites a lot.
I would agree that it would be like a fantastic value add or the opportunity to go add more value, and increase the price, especially on the machine builder side. I would also say that I feel like if you're a machine builder, it's really difficult, right? Because you're a machine builder, you have a request for proposal that comes in. Based upon that
Mhm.
request for proposal, you have to go offer a solution and you have to go give a dollar value, right? And if you, Vlad, were bidding $1, I can't reasonably come in and say, hey, it's going to be $3.57 because I've looked at your thing and I've done all of these other things that I know you're going to want, and then expect the proposals to go be compared apples to apples. Right? Like it's
Mhm.
different if you're looking at like different types of robots. It's perhaps different if, I'm bidding, 5-year-old obsolete PLCs that are sitting in the back, and you're bidding, brand new PLCs or IPCs, sort of solution. So I feel like it's different if we're bidding like physically and significantly different hardware, and there may be some value there, but it's really difficult to, on the first kind of round of proposals, go move an end user, especially an end user who has just completely missed large segments of requirements that people know they want, without going and bidding and being so far off in left field, you're just going to lose the potential proposal and potential opportunity.
Yeah, and again, I think it depends on the groups. I think that not all. end users are made equal. If they don't have a resource that can
Yeah.
clearly call out requirements, on the automation side or on the network side,
Mhm.
yeah, it's gonna just be a flat network. And hey, we want to put the cheapest type of hardware that there is. But again, the more savvy technical groups, right? If you look at the top 50 or Fortune 50 manufacturers, they will have
Mhm.
some IT standards, and you cannot just come in again with
Absolutely.
whatever hardware and just like, hey, it's gonna work. Let's just set these IP addresses and let the machine loose on the plant network, right? There's gonna have to be some, or someone will do their due diligence, and they will have to put
Mhm.
a, when they do the RFP, they will double check like what's
Mhm.
actually there and what's not there, and what is it gonna cost to like make, because someone's gonna make those changes regardless. If they don't realize that they need them today, they will have to then spend more money on site, retrofitting quote unquote this new design into the machine. So it's-
I agree. Generally speaking, the larger the companies, the better, more experienced the resources should be. Having said that, I've read some really good RFPs from smaller organizations, and I've read some absolutely terrible RFPs from Fortune 50 companies, looking at it and saying, you guys are not going to get what you want if this is if this is the proposal that you've put out the door. Best intentions aside.
yeah,
Having said that, Vlad, where do you want to go? I know that we've got a doc,
we do have a doc.
and
Yep.
we have a doc, and we've got some architecture drawings that we did not build.
Yep. So let me, I guess, introduce
Can
this a
we?
little bit,
Yeah,
if
please.
I can. So for those who are listening, and I guess for those who are viewing, we are screen sharing a Rockwell automation architecture doc because they do have quite a few white papers on the topic that you can access for free on the website. And again, I think it's not to say that this is the ideal or the way we would recommend to do some of these layouts, but I think they, at the very least, start some conversations and we can have a discussion around the different areas that are illustrated in this doc, right? And so if I scroll through,
Mhm.
there's going to be simple diagrams, right? So this is going to be maybe a simple or a couple of redundant switches on a device level ring. There's going to be different topologies explained, and there's a lot of different white papers that you can go through. And so our goal today, obviously in the half an hour that remains and even less so, is to maybe pick a couple and start a discussion as to what are some of the pluses and some of the minuses. And so, if I may, here, on the diagram
Mhm.
on the, I guess, bottom center, and we'll try to do this as best as we can for the podcast listeners, we basically have a couple of switches with a variety of different field devices from controllers to drives to IO to soft starters, different flow meters, instrumentation, obviously thin
Mhm.
clients connected. And I think this is a, at least for me, it is a common, question. Well, how do we get all of these devices onto the plant network? And I would argue, the layout here is a little bit complex. For me, the question
Mhm.
usually boils down to, or a recent conversation has boiled down to, first of all, do we want to select, a star or a ring topology? And second of all,
Mhm.
what is the most cost effective way of basically connecting a bunch of these devices that, again, to me, this represents maybe one or maybe two machines at most, um, back to the plant
Yeah.
floor.
Absolutely. Let me ask you a question, Vlad.
Hmm.
I feel like you bring up ring or DLR device level ring. And for those watching live, it is directly on top of the page. If you guys are not watching live, it's in the show notes. I've dropped it in the show notes. We're on page
Hmm.
6 of 87, the top kind of entire enterprise stack. But ring or DLR. Do you, Vlad, have a preference? I know that you've
Hmm.
worked on a lot of specifically Rockwell or Rockwell heavy or Rockwell only solutions. Lots of static switches, things like that. Have you done lots of DLR? Have you have a opinion or at least an opinion that you'd like to share as to if the potential pain of going and setting up a DLR is worth the
Mhm.
added benefits of it.
So it is a very interesting question, right? And what I will say is, for me, it is always surprising when you show up on site and you talk to some of the technical individuals from that specific site.
Mhm.
They're either very for DLR, right? It's like everything
Mhm.
is on DLR, even like two
Yes.
devices. And you'll find
Oh
like a
yeah.
weird, like why was this on DLR? Well, because we want to grow the ring, or they will be very much against it. And I actually
Um,
had a recent conversation, like I mentioned, with a site where the on-site folks were selling me on the idea we only want DLR. None of the devices you're going to put on the network are going to be on a ring topology. And then when I had the conversation with the corporate from the same group, they were very much against DLR because they are unwilling to deal with some of the setup challenges that may come in depending on the version of the hardware as well as the software. My preference is I like DLR, right? And I like it for two reasons. Number one, I I hate dealing with crimp wire challenges, right? So a lot of the electrical groups will, for better or for worse, right, just be unable to crimp Ethernet or RJ485 cables. And so they will sometimes double check their work, but a lot of times they will be left with, I don't have I guess, a picture of one, but basically, the wires are hanging out and the crimp is not on the insulated cable. So I just, to avoid those types of problems, because I can then see in the DLR where the problem is or where the
mhm.
problems are, I can simply tell them, like, hey guys, you need to redo some of these crimps. On the star side, it's a little bit less obvious. Obviously, you will still not be able to communicate with the device. You'll then check the cable and come to
Mhm.
the same conclusion. But if the crimps fail with time, which, like I said, it depends on the cable, it depends on the type of connectors they purchase. Everyone wants to save money, but the right connectors are, on the can be on the expensive side if you have many of them.
Mhm.
I, again, even on that side, prefer plans to buy pre-molded cables. I laugh at this a little bit too, because I would have a panel with a bunch of drives, and the electrical group that's doing the installation is going to crimp, like 2 feet cables. And so it's basically a lot of time
Yeah.
wasted, but also a lot of
Mhm.
potential failures where you can go on a bunch of different devices, like websites like Monoprice, and just get those cables for pennies on the dollar. But anyways, I guess to answer your
Yeah.
question, I prefer DLR. That's reason number one. Reason number two is it saves a lot of money on the networking side, right? So a lot of your
Mhm.
modern device, at least when it comes to Rockwell or many other brands, come pre-configured with two ports, and so you can daisy chain all of those devices without needing an external or an extra switch that you would then manage the star topology through. And that is, again, we can argue about what features you need on the switch. It's easily between, if it's managed, between $1,000 and $5,000
Mhm.
USD, right? So it does make a difference. So for both of those reasons, I prefer DLR. But like I said, I'm more than comfortable if you want a whatever device to manage the ring topology, we can set it up that way as well.
Absolutely. I'm just for the listeners at home,
Yeah.
imagining Vlad going around with a tester or like pulling on all of the ends of like these hundreds of cables that a couple of poor entry level folks have just done. And if they don't look good, just like taking his cutters and cutting them at the end of every shift, and they come back in and like 30% of them are just hanging there. And Vlad is like, not good. Please redo. And
It's yeah, I would say it's less. I don't think it's malicious. It's more,
I'm not saying it's
disappointment in the
malicious. I'm not saying it
craftsmanship.
would be you would
Yeah,
do it maliciously, Vlad. I'm
yeah,
just saying you'd look and say this is not acceptable in my facility. Please go and fix it. But no, I agree.
yeah.
I'm a big fan of the pre-molded cables. There are some times where pre-molded cables don't necessarily make a lot of sense, especially if we're fishing them through unknown lengths and going to have a
Right.
bunch of extra drops or things like that. But if I am connecting, IO, VFDs, some of these instrumentation and other items to controllers or to switches, or I suppose hubs, if we want to say the H word, then I am a big fan of we should know how far away it is or approximately how far away it is. Let's just go by the cable, make sure that we have enough cables or more than enough cables to go do the job, and then continue on from it. The cost of the pre-made cables are not significantly more until you get into huge quantities than the parts in a decent kit to put them together and a decent kit to go test them to make sure there are no issues.
Yeah, absolutely. And like I said, I guess we can talk about the challenges of some of these architectures on the installation side versus, longevity and performance side. But I think it's important to recognize and understand how this is going to be deployed and what it's going to take and where, some potential corners, I guess, can be cut and then
Hmm.
result in downtime down the road. Because there's always, I think there's 1,000 ways that you can get this done, but there's also many ways that you can fall into traps that will cost you a lot more later. And so maybe building on that same thought, right? So again, I think that this cell has quite a few devices when it comes to maybe managing such a small amount of actual, PLCs and controllers and IOs and drives, which is, I guess, a tiny bit surprising. But it seems to me that they are, first of all, doing two types of rings, one for, this controller,
Hmm.
another one for a different controller. They're also displaying a couple of firewalls specifically for this controller. They also have I guess, what's a remote access point for a laptop. They have a
Hmm.
thin client hanging off this specific switch. So I have a couple of comments. I guess I can
Yeah.
start if you will. So number one, I would say I very, very rarely see any firewalls at this layer, right?
Hmm.
So a lot of times they come in maybe at this switch that is, and I guess I don't know how well you can see the mouse on the screen. Obviously, for the listeners, there is a larger managed switch that is trunking back to some of these different zones, but that's where I would expect maybe to have this, when we look at layer three site operations, this is
Yeah.
your ITOT bridge, so to speak, and that's where maybe firewalls would make a little bit more sense. And they call them out up here, as you can
Hmm.
see: planned firewalls, active, standby, and that's I guess, a different conversation. But I guess I'm just a little bit surprised to see this kind of isolated firewall for that specific controller. I almost never see these access points for laptop on the wireless side. The only time I'd say I see them is when you have, a commissioning effort. And,
Hmm.
even myself, if I'm looking to, like, if I have, let's say, Studio or RS Logix 5000 on the engineering
Yeah.
side for a machine that's not connected to a server, well, maybe you have an access point on the panel for the time being, so you can at least walk and, toggle sensors or other devices. Thin client makes sense. I guess it's interesting that it's, once again, I think there's just a abundance of different switches for me
Yeah.
because they're on the ring. They all need to be managed. So this
Hmm.
is just a very, very expensive layout. And of course, they're not showing all of the devices, I'm
Hmm.
assuming, but
Yeah.
it is interesting.
I think with it being the cell or area, I feel like if you
Mm,
look at all three of the cells and areas, they've just kind of added one of everything, right? Like if they have
mhm.
a icon for it, they have added an icon for it. I have a couple of clients who will have um wireless wireless access within the facility, only within the facility, typically only within their physical laptops, with the your facility, you leave the Wi-Fi areas, and you no longer have access to it, and you've got to go back in via a VPN. Having said
But
that,
straight to the OT network, like that,
yes,
like at the
oh,
machine level. Oh, interesting.
yep, straight. Well, and they are generally sites who do a lot of commissioning, right? Or
Okay.
who are actively in the build process. Having said that, they would be higher up, right? Like they would be probably at that distribution switch stack, because it's not broken up into cell or area zones for that connectivity. And you can see we've got several different iterations of Wi-Fi connectivity here. But
Hmm.
I would also agree, kind of similar to the thin client, it is a little strange that the thin client is only at that switch. Although if it's a managed switch, I suppose we can hit everything. But man, there are a lot of there are a lot of switches, or what appear to be switches on this dock. I do think it's good, and I do think it's good that the DLR, the ring topology in the middle, the star topology on the left hand side. I like how they show it with LAN A and LAN B. I like the safety IO on the right hand side. I think there's a robotic arm there. I will say I am a little surprised to see that firewall, per your comment, Vlad.
Hmm.
What I typically see is if we are going to go put a firewall in those areas, like we would put it kind of like the one on the right side. But very infrequently am I going to see firewalls down in level 0 to 1 for that controller, and specifically on a specific controller. Most of the time, if we're doing that, we're doing it and segmenting networks. And so we would be more at that like distribution stack switch level for some of those firewalls, or
Hmm.
maybe above, maybe below where we're breaking out VLANs. But in this instance, I assume we're breaking out VLANs kind of similar to the cell or area zones as we're calling it out here. Again, there may be a reason. Like I could see potentially putting it on a safety controller. I would imagine this is just kind of one of everything. Let's go show double rings. Let's go show stars. Let's go show. I don't see what the topology, what we're calling out on the right hand side is, but like let's go show safety controllers and servos and robots and all of those other things.
Yeah, I think I would agree. I honestly, I don't think there's a lot of value in having all of these switches unless you're segmenting by VLANs. To me, it seems like every connection from switch to switch is labeled
Mhm.
as this sort of blue line, and then every field device is red. There's
Yeah.
obviously different ways to segment VLANs. I've seen
Hmm.
where, a plant is going to throw all of your network devices on one VLAN, then
Hmm.
all of your different areas in like specific VLANs. Obviously, this diagram, and probably you need to read all the text to fully understand what they're doing, but we don't have full context as to how they're recommending to segment VLANs, right? This could be VLAN 1, VLAN 2, VLAN 3, but based at least on the colors, that doesn't seem to be the case. But there is a lot of complexity here too, right?
Yeah.
So they're doing like double pulls between switches, they're
Hmm.
trunking, and that's a setting on the managed switch side. So this
Hmm.
distributes different parameters. But long story short, I guess this is a good general architecture with no unmanaged switches, at least from what I can tell. Otherwise, you would run into a whole lot of problems if they were.
Yeah, no, I agree. I think they all have to be managed switches. Otherwise, that would just be the flattest architecture anyone could possibly find. I think we
Yeah.
go into a little bit more detail
Hmm.
in some. I think we go into a little bit more detail in some of these, but overall, I think it's a really good series of architecture drawings. I don't know if anyone else has spent hours or days or weeks of their life looking at these and being like, "Hey, maybe we could do it slightly better," and then you go try to draw them and turn it into something that everyone will understand, and they are not particularly easy to go ahead and draw, especially if you get above just like physical hardware layers. And then
Hmm.
as soon as you go and get into segmenting into VLAN, segmenting into other ways, are we doing it physically? Are we? And if you're doing it physically, that more so makes sense. But I've had groups who want to go segment based upon which software we're using uh, to have even more segments. As to if it's needed or not is debatable and is always debated. But I would agree with that.
Yeah, I would say, like, look, I guess for me, over the years, I've learned to watch out for certain things, and I believe that's where sort of experience comes in. And simply because you can create a certain architecture doesn't mean it will necessarily work or behave the way as it should. And that's why I like this drawing maybe here, which
Mhm.
illustrates a whole lot of different safety devices, right? And the moment you
Mhm.
start doing safety, and that's a whole other maybe like safety conversation, but if you start doing safety over a protocol that is distributed across the network, you also start running into different types of challenges. And this is, again, when we say, network architecture or architecture and manufacturing in general is simple, right? There's still a lot of nuances. So going
Yep.
back to my example of the palletizer, right? They had hardwired relays. So if they were to put relays or safety devices on a network, that would have raised a third flag, at least from my conversation with them, because then you're putting all of that safety traffic and potentially shutting down the machine as a result of a flood of traffic from the plant, because safety is a whole other ball game when it comes to your network and the
Mhm.
amount of, I guess, like effort it is required to deploy. But I think ultimately, there's a lot of complexity on the side. I think that um there's no one size fits all type of an answer. I do want
Mhm.
us to maybe move into some of the thoughts and conversations on the, brownfield versus greenfield, as well as maybe some of the different industries and different things you have seen in your experience, Dave, when it comes
I
to architectures.
I agree. I think that the brownfield versus greenfield conversation is very interesting, right? I think to some extent, everyone's like, hey, if I could just go rip my facility down, I would, remove ring and go to star, or I would remove star and I would go to ring, or I would get rid of all of these, you know, unmanaged switch hubs, or lightly managed switches, or whatever we want to go call some of these, and go change into like specifically this brand. But very infrequently do we get to see people go through the process of rebuilding their entire OT network. Having said
Yeah.
that, Vlad, I feel like it is more common that I see people doing almost greenfield builds of an OT network in an existing business, right? Of we've got 50 machines, we've got 60 machines, they're not connected whatsoever. We are collecting data on clipboards. Maybe we've got a couple of IoT style devices. And that's how we're collecting information. But we have the raw material count at the beginning of what we purchased. And we've got our end widget count, and everything inside is just kind of a black box of processes. We don't know what processes are going well, what processes aren't going well. So I feel like there are probably a lot of people who are going through the process, or potentially going through the process, or recently went through the process of going and building a legitimate OT network for the first time. I feel like maybe, I don't know, one in four, one in six networks that I run across, or have run across in probably the last 4 or 5 years, like maybe there was a network, but it's very flat, right? Like we can see absolutely no topology. Maybe there used to be a managed switch, or maybe there are a couple of managed switches there, but we may also have, 64 CNC machines or 300 VFDs. And man, those are all dead flat, right? We've just taken our pre-molded cables, we've shoved them into unmanaged switches, and I can go read IP addresses that we've hopefully gone through and created for each of them. But man, I have no idea like where those are physically, what machines they go to, how it's running. So I feel like there is a lot of opportunity to kind of look at almost the greenfield within the brownfield. And I'll just kind of go finish that thought by saying, to a large extent, if the brownfield exists, if there is an OT network, that is the network, right? Like we can update switches, we can add more managed switches, we can add more network cabling upgrade our cat cabling as we go through the process of adding more devices, etc. But to a large extent, unless something catastrophic is happening, or unless there's like millions and millions of dollars of money to suddenly invest in a network, which is very infrequently as part of a major other upgrade, you kind of have the OT network that you have, and it's how can I go spend my fairly limited budget to continue to upgrade and continue to, yes, to continue to upgrade and continue to go through that process.
Yeah, I definitely agree with most of those points. I think that my experience has shown is that I think companies incur a lot of technical debt by, cutting corners early on in what they're going to do. And so there's simply, again, everybody wants to save cost. Everyone wants to run projects on the leaner side internally. And so, of course, engineers are going to get it done with the resources that they're given. But usually, with time, that again, debt builds up. You're starting to run into problems. Someone's going to want to add more things to that network. Someone's going to connect strange things to that
Mm-hmm.
network. And that's where I think networking is still a fairly,
Strange.
yeah, I mean, you can, right? It is a network. You can plug in your phone. You can,
I don't disagree.
so,
Oh yeah, yeah. I've seen like
mhm.
PlayStations plugged in on third shift. I've seen lots of like dual homed computers of, hey, this OT network computer doesn't have the internet, but man, I'd really love to go scroll Facebook while I am not paying attention to work, or I'd really love to go. I've seen Facebook on
Yep,
HMIs on IPCs. Uh,
absolutely.
it's amazing what people will get to if it is not locked down. So no, there are definitely strange, weird things that we can see people um, going and
Yeah, so I
creating.
think it's definitely a hard sell, right? Because ultimately just upgrading a network or the architecture just for the sake of upgrading is a very difficult value proposition because a lot of the ROI is not directly tied to said upgrade, right? It's more tied to, hey, we're going to
Mm-hmm.
deploy this SCADA and MES that will collect the data
Yeah.
that will, if we run the appropriate, CI initiatives, result in an ROI in a set
Mm-hmm.
period of time. So then it's like, well, can't we just do it on a flat network? Well, in theory we can, and then maybe there will be problems, maybe there won't, right? So it's a very murky area, I think, for many organizations. And the same goes for attribution, right? So there was a very long thread based on the Copia DevOps report. I don't know if you've seen it on the Jeff Winter side, but basically when you have network problems, you're rarely going to get very specific faults, right? So a lot of downtime that results from network issues, again, let's say in the instance of safety devices, is not going to be attributed to networks. It's going to be attributed to, well, there's a software
Mm-hmm.
problem where there's like a, that point IO module has failed, so it's a hardware fault. And we're going to think, hey, like we need to replace
Mm-hmm.
this safety circuit, right? But the reality was that
Yep.
just you cannot capture that packet unless you're actively looking, and you're probably just going to reset the
Mm-hmm.
HMI, or I guess the machine via the HMI, and just let it run. So it's very difficult to troubleshoot network and architecture problems, at least in my experience, and that's why less groups have visibility as to how much downtime they actually incur as a result of those problems.
Yeah, and I would say to that extent, there are not a lot of groups who would go attribute half a day of downtime, several days of downtime to we've got
Mhm.
a network problem. I have had a couple of clients over the last year or so go look at the facility, recommend some additional or significant networking work because there are potential issues there. We can go quantify how much networking downtime costs these facilities. And even if I think it's a low number per hour, it's the number per hour that they're using. And, the weekend before you get there, they're down for 18 hours because of this
Yep.
networking problem. And they just 100% refuse to believe that they took downtime because of
Yep.
networking. So I think a lot of it is I think a lot of people kind of think of the networking like you think of your laptop or you think of your phone, right? Like it's going to work. At some point, it's not going to work. I'm going to go buy another piece of hardware. We're just going to go plug and play and go solve that problem, and then we're going to be able to move forward. Sadly, it's not that case. But I would say I feel like in the last 2 or 3 years, maybe more, we've been having more and more appropriate conversations about the
Hmm.
OT networking. But I feel like it goes back to one of the very early points that you were making, Vlad, of hey, if we don't segment this network of this palletizer, we're going to go have problems. They don't want to hear about the problems. They don't want to go 6 months ago when they ordered the palletizer, consider the networking implications or ramifications or switches or hardware or other things we need to buy. But suddenly, as soon as the palletizer isn't working, oh no, we've got to go bubblegum and duct tape this network together in order to go solve this problem. So I agree. I think that the network is very much the unsung hero of facilities that continue to be up and
Yeah,
running.
absolutely. And like I said, I think both you and I have many stories on that side. I think it's again just educating maybe some of the groups to realize that the problems are related to networks and not, software or hardware or something else where, all they're doing is
Mhm.
resetting the fault. I do want to, I guess, like make a couple of comments which are listed on our doc before we wrap up. I think for me, an important distinction is also between different industries, right? So, for example, if you look at food and beverage, CPG, pharma, or sort of this like large plant, even an oil and gas refinery, perhaps, you have these highly concentrated networks and a lot of different devices on that side versus if you look at oil and gas as a general industry, their networks are again very distributed, very cellular connectivity dependent. So they're going to be buffering a lot of that data, right? So then we can even have the conversation of what components they need as a result of their architecture being different, which I think is very interesting, right? So you'll see a lot of
Mhm.
challenges solved by third party modems, right? So in your I guess oil and gas types of applications, it's like smaller PLCs, so it's a lot lower traffic bandwidth, but it's so many like different remote areas where you cannot run a physical connection or a cable. So I think it's interesting also depending on the industry. There's some industries where you need to have networks on the move, so to speak, right? If you have anything
Mhm.
that's like moving, like for example, I know like trains are technically like industrial plants, so to speak, on wheels. So, they also rely on sending some of that telemetry data back to a location via connection devices. But yeah, it's just different architectures and things are set up a little bit differently. And maybe you can have a flat network there because it's just a very small amount of devices. So that is interesting as
Mm.
well. I don't know if you have any thoughts on, different industries and interesting maybe insights when it comes to architectures.
Oh, I mean, Vlad, now I'm over here
Mm,
pondering trains. And I'm over here thinking to myself, I mean, they could have a significant number of cars. They could have a small number of cars. Those cars couple and uncouple each other. So I would imagine that each of those cars would need to be its own, I don't know, VLAN, would need to have its own
my,
managed switch of some sort.
you- I don't know. I would be very surprised if that's
Why?
how they do it, but maybe.
Well, I mean, you don't think they want to be able to know the difference how car 3 is running versus car
But why can't you do
47?
that versus
Like
like
you
a
don't think
just like
like it,
a array of digital IO that is basically adding onto like a chain, like a daisy chained IO? No, we're gonna have to bring in like a
I don't
trained
know.
person
I
that like
I
does a walkthrough manufacturing hub live in person.
Wow, but I feel like you and I were doing really well on this episode until you're like, let's go talk about different industries. I guess my point is more so, and I don't know how they would do it, and I don't know if they are running um industrial control systems on it. I don't know how they're doing. I guess my point is more so you have
Hmm.
the engines, you have the various different types of human
Hmm.
cars, you have the cars that hold all of the cargo, right? So those flatbeds. And so you probably want to be able to easily delineate across which car, what type of car it is, and what are the attributes for it, right? So like if I have a brake that's failing, I probably want to know where that is, as opposed to it's one of the 400 or 4,000 brakes on this train, right? Like I probably want to be able to easily go define which brake it is within which car, and then which train it is across all of these other trains. Like I have to imagine they want to be able to go watch those trends on each of the trains, and the trains could, assumingly depending upon the different types of trains they are, have different cars added to them and have cars taken away and the cars move and all of these things. So I feel like we should end it there, because otherwise we're just going to go on like a 6 hour deep dive of
Well,
trains, which is this is not
I
the
think we
train
I
hub.
think we will have to get to the bottom of this. A very,
Oh, we will get to
very
the
brief
bottom of
search
this.
tells me that the physical protocol, or I guess connectivity, is via RS-485. I don't know if that's still in use, but we will have to.
I mean, if it's via RS-485, we're almost
Yes,
certainly
we'll
all
have to
wrong.
talk to some modern train people, right? There is an IEC 61375 standard set, which hopefully Dave reads through before the next conversation and reports to see if the
Yeah.
cars have individual managed switches, which would really surprise me, but could be interesting. Let me, I guess, like wrap up with the final topic, which again we talked a little bit on the early side, and I did want to get your opinion on this. So, end users versus integrators versus machine builders. Let me ask you, I guess, in a slightly different variation as to not who is to blame,
Mhm.
but who do you see usually being the most savvy stakeholder when it comes to these network architectures, and who would be, I guess, helping the end user establish a proper standard? Is it internal? Is it an integrator partner? Is
Mhm.
it a consultant? Is it a machine
Mhm.
builder slash OEM?
So, we'll take two tracks, right? So, like, if
Mhm.
you are a greenfield, I mean, so if
Two
you're a
train tracks.
greenfield, two train tracks diverging. Uh,
Yes.
Wildest clips ever coming from this show, Vlad. But no, two diverging train tracks. If you are on the greenfield side, and so if you're an end user building on the greenfield side, I will, unless you guys have like a ton of internal knowledge, implore you to go pick a prime contractor and go ask a lot of questions to that prime contractor along the architecture side, right? About hardware, about software. Hopefully, you have decided, hey, we want these PLCs or this flavor of hardware. Hey, this is our SCADA, MES, PLM, LIMS, CMMS, etc. stack on the OT side, and have gone to see like examples or other things of what those guys have built, or you have sectioned off some of that work for a kind of niche group to go ahead and build and provide that. So having said that, um, go lean heavy on your prime contractor or your prime contractors. If you don't have a bunch of that experience, I would suggest or recommend that you hire someone. The work when I do it is I generally call it as like a manufacturer's representative. So like go through and make sure that we have answered a bunch of those delineated questions to make sure that you can get set up at a level that will go through the process of providing success. Having said that, like 95+% of you guys out there do not work at a greenfield. So if you're at a brownfield facility, uh, unless you have some sort of contract in which you are working with someone and they are responsible for your OT network and all of that, a lot of that responsibility at the end of the day falls internal to the end user, whether to go bring in someone, be it a networking specialist, go upskill the people internally, or go make sure that you're asking the right questions to any of the machine builders or other people and go have your standards, right? I've said it before. I probably haven't said it in this conversation, but end users should go have a standard stock. Yes, end users should go have a standard stock so that they can go through the process of saying, hey, if you're going to build on our system, this is what we need all of these items to go look like. PLC naming, up through networking, up through hardware recommendations, up through color and variation, and everything else. And generally speaking, the larger the organization, the higher probability that they will both have one of those standards documents, send those standards documents with the requirements, and force people to actually go follow those standards documents. That's
Yeah.
I think that's my short spiel and feelings on that, Vlad. Do you want to go kind of share some of those thoughts that you have?
I think it makes sense. Almost the way you describe it would be hesitant to say that some kind of an external group should probably share some of those network layouts and, I guess, best practice architectures. But I am hesitant to make that recommendation because, again, I think it's just going to spawn yet another standard from what already exists. And I think that
Yeah.
just like everything else in our space, multiple groups will be fighting on saying that their standard is the one that you should be following. And so I guess there is no one size fits all answer in this specific instance. Um,
I
hmm?
think talking about standards is that as I talk about standards, it is very much in the it is very much in the thought and the realm of every organization should have their own standards, right? Outside of that organization, you do not have to agree upon those standards with that organization, but end user, large organizations should have standards of this is what we are going to accept so that everything works well in their facility. There is certainly value to having all PLCs be not only the same brand, but like one of three versions of this PLC is the only thing that we're going to accept. If we want ladder logic, if we want structured text, if we want a different programming language, right? Like these are the things that we accept. It has to go tie into these systems. It has to go tie into existing systems. This is the data that we're looking for. This, at the end of the day, is as critical, nearly, or maybe more so, than like the runoff requirements, right? So like if I can make
Hmm.
5 widgets an hour or 5 widgets a minute, that's fantastic if it's the requirements. But if I have none of the data to prove quality, if I have none of the data to understand how the machines are working, at the end of the day, it doesn't matter that I can make 5 widgets because we still haven't implemented the thing that was required to be implemented.
Yeah, and I will certainly put out some content pieces on that front, obviously providing some general advice on which standards make more or less sense. But again, I think I would be hesitant to walk down the path of creating yet another standard because I think it is highly dependent on the organization and, as you said, dependent on the vendors you're using. And there could be almost, well, I don't want to say on the network infinite complexity, but there can be a
Mhm.
lot of complexity as to what your system currently looks like, what you're using, what you're looking to do, and what your business ultimately objectives are. So
I guess at the end of the day, I think of it, and we'll go back to the first story that you were sharing, Vlad, or one of the stories that you were sharing when we were talking about DLR versus Star,
mm,
of the local guys all wanted Ring. And the corporate guys were like, no, we want to go Star topology for this reason. if there's a corporate standard, there's no question, right? There's no question. There's no infighting. There's no Vlad being, who cut the purchase order? Which one of you guys are signing off? Yes, it's good because you are the person that I need to appease, right? Like there are none of those questions. This is our
Well, in
corporate
theory,
standard.
no. You say that in theory, no, but once we walk off site, who's to say that that's how it's going to remain, and the local guys are not going to reconfigure it back to a ring topology? Like nobody knows.
Well,
So
I mean, at that point, it's not on you
yeah,
as to what do they do after it's been signed off and good. If they decide to go completely destroy their system
mm,
and go change topologies because that's the way they want it, then that's the way they want it. But at the end of the day, then that is to corporate who has one site or 50 sites or 500 sites to go and understand what the topology and to go understand what the topology looks like at those sites and to go push those corporate standards down to the
yeah,
bottom. Again, very rarely is corporate not involved at the major project level that I am working, or is not involved in the
hmm
standards. Um, yeah, every once in a while, we've got sites that want to go do this thing and corporate that wants to go do this thing. And it's at some point they'll go figure it out, but that is almost never within my scope.
good. Let's do we want to wrap up with the usual questions? And I guess if so, let me start by predicting the future a little bit. I
Okay.
I honestly, based again on my engagements, feel like things will get worse before they get better. I think when it comes to networks, at least, again, I think that there's more and more devices being added every single day. We want more and more data being, I guess, pulled out of the plant floors. And I think we're still not realizing the importance of some of these networks, right? And a proper architecture that then scales with the, I guess, the manufacturer, so to speak. And so I think what's going to happen is we're going to keep adding until things break, and then we're going to realize what kind of technical debt there has been over the years, and we're going to have to some extent, gut and replace, or rework some of the areas. But I think that realization will be fairly difficult for many manufacturers. And I think, especially when a
Mhm.
lot of them model themselves to some extent with the ideal or utopian world for you can read a lot of different case studies with some of the top manufacturers, but I would say the middle ones are not going to release their topologies and the real challenges they're facing. They're going to try and get the same type of data information at the SCADA and MES layers. They're going to fail because they don't have the right architectures, and they'll have to go back to the drawing board and sort of rework quite a bit of that. And I think in maybe 3 to 5 years, things will get better. But until then, I think not enough importance is being placed on the networking side.
Okay. All right. I think that is a good prediction. I will agree and double down saying that the last, I don't know, decade, there has been a significant request for more and more
Hmm.
data. We've added more systems, we've added more solutions with the rise in popularity of AI. Like it or love it, there is only going to need to be more data passing through these antiquated OT networks, and RS-485 isn't going to get us there. Our RS-485 or 382 are not going to go
You're
get
telling me
us
the
there.
trains are not
So
going to have AI?
the trains are already sentient. The trains are definitely already sentient. But no, I imagine that we will see from the smarter forward thinking groups significant infrastructure upgrades as part of some of these offerings, be it in MES, be it a updated SCADA, be it an AI solution, call it whatever we want to. I imagine that the forward looking organizations are going to go ask these questions, or maybe they get to the point of, hey, we really like this, now we've got to go rebuild our network now we can go get more and go to phase two. So I imagine that, but I imagine that there will be a decent 30+% of organizations who 3 years from now, 5 years from now, will still have their very antiquated OT networks, will have none of this data and information, and still won't be able to understand and commit and comment as to, hey, we are having these problems. We don't know why we're having these problems, and not have the ability to go troubleshoot those
Yeah,
solutions.
absolutely. Career advice, I guess for me on this side, I'll keep it short and sweet. I think I've mentioned this in a couple of episodes. If you're looking to learn networks, I think CCNA is definitely a good route. Obviously, it's leaning towards Cisco equipment, which is what you'll find under the hood of the Rockwell switches. But I think it's more the principles of configuration and the different protocols on the networking side rather than the specifics of the actual hardware that matter the most. So I think if you want to build your knowledge, I think it's an excellent starting point.
I think that is good. I think my career advice is going to be slightly more broad than that. But when it comes to areas that you are unfamiliar with, go ask questions. Ask lots and lots of questions to people, especially people who seem willing to go answer those questions within your organization, with outside of your organization, as you're going through and networking and talking to other people, and be willing to kind of share and listen and say, hey, we've got this problem, or hey, we're looking at this. Have do you have an opinion of ring versus star topology? Do you have an opinion of Stratix switches versus Siemens switches versus Hirschman switches versus all of these? And most people will be very opinionated and have a lot of opinions.
Hmm.
So I think that's good. Content recommendation wise, I am going to kind of mirror Vlad's content recommendation when it comes to networking. So if you guys missed last week, in fact, episode 228 with Gavin, we had a great conversation talking about cybersecurity, and I think like two-thirds of it or thereabouts was very hardcore on the networking side, right? And how networking and cybersecurity go hand in hand, very much along the lines of having to go through the process of understanding networking in order to be successful on the cybersecurity side. I would say beyond that, a couple of good episodes to watch. And we had a couple of episodes with Josh Fargis. We'll have to go look those up and drop those in. Josh, absolutely fantastic when it comes to the networking side
Hmm.
of things. And would certainly suggest taking a listen to those episodes and watch. He puts out some really interesting blog posts, and he's done some fairly in-depth analysis when it comes like switch to switch and other hardware comparison that they've put up on their test benches, and done a seemingly good amount of stress testing too, and is able to go ahead and share that publicly. Vlad, your side content recommendation?
I guess book wise, I have been listening to I guess, business slash motivational book called Winning. So it's just I guess, a principle of doing more than what you would like. And it's, in life, in business, in work, in whatever else. Obviously, there's like principles and underlying perspectives there as well. But just in general, I think it's a good perspective to have. And I will publish the name and the link for those who want to check it out.
Absolutely. No, I think that is. I think that is good. I think that is interesting. I don't know who. Someone definitely has recommended that book in the past. I don't know if you can remember
Mm,
who recommended
possibly.
that book, but I definitely remember that book being a recommendation. Last question for you, Vlad. Who should reach out? Who do you want to chat and connect with?
So I would say, I'm having conversations with two groups, two very distinct groups, both of them in the manufacturing and industrial automation space. But one is obviously the end user who's looking to either automate or make their facility better, and the other group would be consultants operating in that space, whether that's in the context of, consulting for end users or consulting for groups like private equity or some other stakeholders. So interested in speaking with, to be honest with you, anyone involved in manufacturing, But I would say that both of those segments have very different priorities, but happy to talk to both of them.
Absolutely. No, that's fantastic. I would say on my side, if you guys enjoy Manufacturing Hub and like listening to the conversations Vlad and I get to have, or the conversations we get to have with the guests, please make sure to follow along. Lots of you guys do every week, so please make sure to follow along, drop a comment, connect with me, say hi. On the work on the commercialization side, a lot of the
Mhm.
work that we've been doing at Kaplan has been in the ignition ecosystem. So if you guys are looking to go to the ignition side, if you guys are looking to expand ignition from SCADA into NES into some other solutions, or you're looking to go talk about hardware software architecture, I'm happy to go ahead and have any and all of those conversations. Please feel free to say hey. Yeah, please feel free to say hey. And if we want to have a conversation, happy to. If not, please follow along so you guys can catch every episode of Manufacturing Hub every week. Having said that, if you guys have made it this far, fantastic. Thank you so much. Vlad and I have already asked you guys to connect with us. So I'll say, please go connect with Manufacturing Hub. If you guys are watching on YouTube, if you guys are watching on Twitter, if you guys are watching anywhere else, please go hit the subscribe button, either on the Vlad X channel, on the Manufacturing Hub YouTube channel, so that you guys can follow along. We have these awesome conversations every week. Next week, we're jumping back in and having some conversations on the AI
Mhm.
side, which should be super fun, super exciting. I feel like at the beginning of 2025, we're like, hey, we should go have an AI conversation AI theme. And then we're like, hey, I don't know if we can put 4 conversations together to go talk about AI. But I don't think we made it more than like 2 or 3 weeks without having some conversation that included AI in the last 6 months, which is pretty awesome. So it has been very interesting to go watch this expand. This will actually be a follow up to a previous conversation that we've had, and we want you guys to go hang around and watch around for that. If you guys are on YouTube, if you guys are listening on podcast form, you're absolutely amazing. Please go hit that like and subscribe, that thumbs up button, the like button, all of those other things. Follow along, share, subscribe, do all